Welcome to part 2. Part 1 ended abruptly when my battery died on the phone. So we're up to 38.6 degrees C. And we'll hit this. N2 gets the wattage. And it's pretty cloudy outside, you know, it's gotten worse. And so we're somewhere around 50 watts. Now I started with 17 degrees C, and so it's been 2 hours, and up to 2 o'clock right now. We started at 11. Maybe that's 3 hours. But this thing actually works pretty good. This was sent to me by a viewer, and I'm really thankful for it. This one failed, and they asked me if I could fix it. They also said they didn't want it back, but I could play around with it. And it's really kind of a nice unit, I think. You know, it's got a few little issues. It's built pretty well. They've hardened up the traces for more current. You have a current sensor right here, and the FET is underneath. This is the big heatsink here. And it's an IGBT. Now the problem with an IGBT is that basically it has between 1.7 and 2 volts across it that is just lost. So, you know, at 10 amps, this thing could be dissipating 20 watts. That's 20 watts that you're losing. It's also basically about 2 volts that you're losing from your PV panel to your heating element, and that affects things quite a bit. As I said, it's a European design. It's an older design. That's back when you wanted higher voltages. You couldn't use a FET. You had to use an IGBT and deal with the heat issues. But now there are lots of FETs that are pretty good. I mean, even a cheap FET will go, you know, you can get a 50 amp FET that's good for 200 volts. And so I'll be bridging in a FET across this to just show you what kind of performance you'll get out of it. But it's not a bad unit. This is the big issue. There's just not enough capacitance. The capacitors are consumer rated. They're not rated for pulse duty. They don't have a low ESR, and you really need, I have one extra capacitor in here. I would really put 2. So 2500 microfarads is probably the minimum I would want to use with this thing. And you can see the thing kind of dancing around a little bit. This cycling back and forth, that's the hunting. Now this is the AC ripple. So let's again look at this. So there's some big voltage swings on that capacitor. But if we look at this display, this shows the voltage. No, that's the temperature. So N1 is the voltage from the panels. That's the wattage. And N3 is the temperature. None of this is explained in the manual. This is like the worst manual ever. There's so many things that are issues with this, and it's not because it's a bad translation. I don't think even the Polish people know how to hook this up correctly or what they can actually get out of it. But this black wire here goes to the water heater. That's a 2.5 gallon. And this water heater has a separate well that you can put a temperature thing in. besides its own thermostat. So it's designed to not have arc interrupt, but it would be very easy to add arc interrupt to this device and software, and that would be really nice for some people. You got to supply 12 volts to it, and it has to be an independent floating supply. So you can use 12 volt switch mode power supplies. Those will all work on DC once you get up above 80 volts or so. Now, there's something unique about this, is that this little minus, if you hold it down, you get the dashes. I have this set for 30 volts. So this thing absolutely won't do any tracking or anything else until it sees 30 volts. And that means that if you have maybe my camp is a 60 volt supply, you could set it for around 60, 59 volts. And it could act as a diverter. Now, their latest version, which is in a nicer cabinet, does not have that feature, as far as I can tell. But like I say, there's another connector here, which will operate it's a dry contact. You can operate a separate solid state relay for emergency shutdown. So one of the things, they talked about that it would have error codes if there was a failure. And they were talking about over temperature failure. Well, what I'm going to do right now is I'm going to short out the output transistor. Why is that not working? Let me go. There you go in the menu. Okay, this is voltage. So when I short this out, yeah, so that's a direct connect. So you can see the voltage goes down to about half. See, it's at 11 volts. And in PowerPoint, it gets up to 36. I'm running, if you can see that orange wire, there's an extension cord that goes down to the basement, goes out to some panels, and that's got about 2 ohms resistance. And these panels should have a power point about 40 volts, and that's the reason you're a couple of volts down from that. But it's a pretty nice little unit, if you go and put the extra capacitors on it. Now this one failed, and it failed because of lightning, and the owner of this was very disturbed because the manufacturer would not respond to them at all. He was trying to get some warranty on this. I'm not sure they would have done it because there was a little diode right here, and that was a TVS, and that's across the IGBT, and that shorted out, and so that indicated to me that there was a good lightning strike on this, and it took out the TVS, which is, it's a protection device, and well, it did what it was supposed to do. Unfortunately, for most of you, that renders this inoperative. I'm going to put a diode in here because IGBTs don't like reverse voltage, just a regular diode. And externally, I have some TVSs, PK68Es, I don't know what they are, but they're 68 volts. And you can put TVSs in series, and so at the output, from ground to the drain of or collector of the IGBT, I'll just put an external TVS on that. Might put a mauve, but that will protect it, and if it goes bad, they can just replace that unit. But I mean, you know, if you have to buy something commercial, this isn't bad. These aren't cheap. They're about 200 bucks. So there's the fan just came on. So I'm up to 40 degrees in really poor weather. That heater is 8.5 ohms. And you can see the results over time. And I'm only pulsing at about 4.2 amps peak. You can see how the thing hunts. But look what happens when we take away the big capacitor. This is the ending voltage, and it has to charge up again, discharge, and then it's charging up again. And there's the AC voltage on the capacitors. And it just works a lot better with more capacitance. Like I say, if we put an extra capacitor on this, I think this would be quite a good unit.